Okay, so quiz tomorrow is on 3.1 and 3.2. There is a calculator part and a no calculator part. So the graphing ones you'll have to do without a calculator. So let's take a look at the first part here. So we have exponential equations and log equations. These two are like helpful. Remember how we had a cheat sheet last test? This is like your little cheat sheet for this one. So whenever we have an exponential equation, when x is in the exponent, our domain is negative infinity to infinity. The range is based off the horizontal asymptote, and that is if we have a vertical shift. So if we add anything to the outside, so we have a vertical shift if we add anything on the outside, and that is whatever that number is, that'll be our horizontal asymptote. We don't have a vertical asymptote because we're either going to have one or the other. So if we have a horizontal asymptote, we don't have a vertical one. And then to find the y-intercept, we plug in 0 for x. So then log, everything's kind of switched. The domain is based on the vertical asymptote. The range is negative infinity to infinity. We don't have a horizontal asymptote. To find the vertical asymptote, we set whatever's in the parentheses equal to 0. So we'll have like log base 10 of x plus 2. We would set that x plus 2 equal to 0 to find the vertical asymptote. And then to find the x-intercept, we plug in 0 for y. So these are super, super helpful to know for the quiz tomorrow. So looking at number 1, we want to find the domain, range, horizontal or vertical asymptotes, x or y intercepts, and the transformations and graph it. So let's start with our domain. What would my domain be here? Is it an exponential or a log graph? Exponential because x is in the exponent. So what's my domain for exponential graphs? Thank you. Negative infinity to positive infinity. Now the range and the horizontal asymptote go together. And those are determined if I have a vertical shift. Do I have a vertical shift here? Yeah. What number is that? -1. This -1 tells me I'm going down 1. So I have a vertical shift down 1. It means I have a horizontal asymptote at what? Y equals -1 because it's a horizontal line. So if I were to graph that, I would go to -1, put a dotted line through it since that's my asymptote. And I'm going through the y-axis. This is my y-axis. I'm going through the y-axis at -1, so it's y equals. All right, next we want to find, what's the range? We can save the range for last because here we have a reflection going on. So it's either going to be from -1 to infinity or from negative infinity to -1. So we'll save that for last. Let's find our vertical asymptote. Do I have a vertical asymptote? Nope, because if you have a horizontal, you're not going to have a vertical. Do I have an x-intercept? So for exponential equations, we have a y-intercept, so we don't have x, but we'll have a y. How do I find the y-intercept? Plug in 0 for x. So I'm going to plug in 0 for x and solve. So I'm going to plug in 0. I have -2 to the power of 0 plus 6 minus 1. So I'm going to do 0 plus 6 first, which is just 6. What would I have to do next to solve this? What's 2 to the power of 6? So this would be negative 64 minus 1, which is negative 65. So my point here for my y-intercept is 0, comma, negative 65. And we don't have an x-intercept since we have a y. So that point, I would stay on 0 and go down 65, so it's way, way, way off our graph. Let's say this is 10, 20, 30, 40, 50. I'll put it down here. How can I find other points on my graph? Plug in other numbers for x. So what do you think another number to plug in? Another good number. Negative 1. So I have negative 2 times negative 2 to the power of negative 1 plus 6 minus 1. So this would be negative 2 to the 5th power. What's 2 to the 5th power? 32. So this would be negative 32 minus 1. So negative 33. So I plugged in negative 1 and got negative 33. So my graph, I would go to the left one, down 33. I don't know why I plotted 34 and 45. I meant to say 30 and 40. All right, what do you think another good number to plug in here is? Negative 2. Why did you say negative 2 and not positive 1? Right, because when we go in the positive direction over here, they're going to get bigger and bigger. So the bigger numbers I plug in, the bigger my y values are going to be. So I want to plug in negative 2, and that'll give me something a little bit smaller so I can kind of see the shape of my graph. So let's plug in negative 2. So I have negative 2 to the power of negative 2 plus 6 minus 1. So negative 2 to the 4th power. What is 2 to the 4th power? So negative 16 minus 1 would be negative 17. So my point here is negative 2 comma negative 17. So we would go to the left to negative 2. And down negative 17, which would be right there. Once you have 3 points, you can graph. If you want to plug in more points, you can. But our graph will look like this. As we get closer to the horizontal asymptote, our graph is getting closer to that horizontal asymptote, and they'll go out to infinity together. So it doesn't like U-turn or anything. It gets really, really close to the horizontal asymptote as it goes out to infinity. Now, going back to the range, what do you think my range is here? Looking at my y values. Remember, range is y values. Does my graph go up to infinity? No. Negative infinity to negative 1. Always for our range here, we're going to have parentheses because it's not going to touch negative 1. It'll get really, really close. But we have a horizontal asymptote at negative 1, so it doesn't touch it. And then lastly, let's just name our transformations here. So we know that that minus 1 on the outside tells us we go down 1. What about the plus 6 on the inside? Left 6. And then what about the negative out front? Flips it on what axis? X-axis. So it's a reflection on the x-axis. That's why our graph, instead of being that normal shape, like an exponential graph, it was flipped on the x-axis, so it goes down. So that's why our range changed too. Yes, Caroline?
So we only need to show the one with the reflection? Like we're not showing the original?
No, you'll just have to graph like the graph it gives you, so you don't have to start with the original. All right, let's look at number 2. All right, let's start with the domain. What's my domain here? Negative infinity to positive infinity. For exponential graphs, your domain will always be negative infinity to positive infinity. And let's find our range. Range goes with the horizontal asymptotes. And horizontal asymptote shifts if I have a vertical shift. Do I have a vertical shift here? Am I adding anything on the outside? No. I don't have any big number out here that I'm adding that tells me my graph goes up or down. So what would my horizontal asymptote be? I have one, it just doesn't move, so y equals 0, awesome. And then do I have a vertical asymptote? No, because if I have a horizontal, I'm not going to have a vertical. We don't have x-intercepts for our exponential graph. We can, but we're not going to be able to find it. So it's possible that we will have one, but you would need a calculator to find it. So x-intercept would be none. How do I find the y-intercept? Plug in 0 for x. So I'm going to do that on the side over here. These are my x values, and I'm going to get some coordinate points. So I'm going to plug in 0 first. So I have 1/3 times 2/3 to the power of negative 2 times 0 plus 1. Let's solve. So negative 2 times 0 would just be 0, plus 1 would be just 1. So 1/3 times 2/3 to the power of 1. What's 2/3 to the power of 1? Just 2/3. How do I multiply fractions? Multiply the numerators, multiply the denominators. So this would be 2 over 9. So my point here is 0, 2 over 9. So that would be my y-intercept. Yes, go ahead. So I'm going to plot my horizontal asymptote. So it's y equals 0. So it's just horizontal line through 0. And then I'm also going to plot my y-intercept. So I stay at 0, go up 2 over 9, which is less than 1. So I could just say it's there. What can I do next? Plug in more points. So I plugged in 0. What's another good number to plug in? 1. So I have 1/3 times 2/3 to the power of negative 2 times 1 plus 1. What do I have to do first to solve this? Negative 2 times 1, so that would be negative 2. And negative 2 plus 1? Negative 1. What does a negative exponent do to the fraction? Flips it. So this would be 1/3 times 3 over 2 now. So the 3's cancel, so this would be 1/2. Perfect. So when I plugged in 1, I got 1/2. Is 1/2 bigger or smaller than 2/9? Bigger. So it's just going to be a little bit higher on our graph. So I plugged in 1 and got 1/2, so it'll be up there. What's another good number I could plug in? 2? Sure. So I have 1/3 times 2/3 to to the power of negative 2 times 2 plus 1. So I have to do negative 2 times 2, which would be negative 4, plus 1 would be negative 3. How do I do 2/3 to the power of negative 3? What does a negative exponent do? Flips it. So this would be like saying 1/3 to the power of 3 halves. 1/3 times 3 halves to the power of 3. So I got rid of that negative because I flipped it. Now how do I cube this? Perfect. You have to cube the numerator and the denominator. So this would be 1/3 times 27/8. And then 3 goes into 27 9 times, so this is 9/8. So I plugged in 2 and got 9/8. 9/8 is a little bit more than 1, so it's going to be a little bit higher. And then once you have a few points, you can plot your graph. Do you guys have any questions here? Oh, what's my range? 0 to infinity. My graph is going up, so it's going to go to infinity, and it's always going to be the same number as your horizontal asymptote. Yes. Well, what does multiplying by a fraction out front tell us? Perfect. It's a vertical shrink. What about the negative that's being multiplied to x tell us? So negative out front is a reflection on the y. What about multiplying x by 2? It's a horizontal shrink. And then the plus 1, adding 1 directly to the x, what would that do? Left 1. All right, let's look at number 3. So for logs, let's find our domain and the range. Which one would be easier to find here? The range, because now range is always negative infinity to infinity. So before, for exponential, our domain was always negative infinity to infinity. Now our range is. How can I find my domain? Set what's in the parentheses equal to 0. So this would be 4x plus 1 equals 0. And we solve for x. So subtract 1 on both sides. 4x is equal to negative 1. Divide by 4. So x is equal to negative 1 over 4. So my graph, my domain would be negative 1 over 4 to infinity. And then what is my vertical asymptote? Go back to the little chart up here. How do I find my vertical asymptote? Set the parentheses equal to 0, which I just did. So it's x is equal to negative 1 over 4. So the vertical asymptote and your domain are always going to be the same number for log graphs. Do I have a horizontal asymptote here? No. If I have a vertical, I do not have a horizontal. Now here I'm going to have an x-intercept. How do I find the x-intercept? Set the whole thing equal to 0. So I change y to be 0. So this would be 0 is equal to log base 4 of 4x plus 1. Now how do I solve for x? Awesome. So I start with the base and then just flip the other two. So it's 4 to the power of 0 is equal to 4x plus 1. What is 4 to the power of 0? So 4x plus 1 is equal to 1. And then what do? Subtract 1. 4x is equal to 0. Divide by 4, so x is 0. So what would my point be? 0, 0. I plugged in 0 for y and got 0 for x. So 0, 0. And then for log graphs, we typically don't have a y-intercept. It can cross the y-axis, but it's not as easy to find. We would need a calculator, so you're not going to have to find the y-intercept. 3 points is enough for each graph. For log graphs, you won't have a calculator to plug in the numbers here. So we start by plotting our x-intercept and our vertical asymptote. So my vertical asymptote is a vertical line through 1/4. So if that's 1, it would go here. So it's important for log graphs to know your transformations. That way you know which direction your graph is going to go. So if I multiply x by 4, what does that tell me? It's going to be wider. And then if I add 1, up 1. So just for logs, I think it's good enough just to know the direction. You just need to know your x-intercept, plot your vertical asymptote, and it's either going to go this way. Unless there's a negative, then it's going to flip in the opposite direction. So if you are multiplying by a negative in here, then it goes in the opposite direction. So it would go down. So again, for log graphs, you only need 1 point. Yes?
What if the log is also?
So if the negative is on the outside, then it's a reflection on the x-axis. So it would flip the whole thing like the other way. That way. It would flip that way. Yeah. All right, so let's look at 4. 4 is a good one because it has a negative. If you're looking at the answer key to this, which I posted the answer key, we recently changed this to be a negative on the inside, so the answer key doesn't match up. But we wanted to practice one that had a reflection, so that's why we changed it. So let's find our domain and range. What's my range here? Negative infinity to positive infinity. How do I find my domain? Set the parentheses equal to 0. So that also helps me find my vertical asymptote. So this would be negative 2x plus 7 is equal to 0. So just what's in the parentheses gets set equal to 0. Subtract 7 on both sides. Negative 2x is equal to negative 7. Divide by negative 2. So x is equal to 7 halves, or we can just say 3.5. 7 halves is fine too. So my vertical asymptote is what? X equals 7 over 2. How do I find my x-intercept? So the entire thing equal to 0. I plug in 0 for the y. So this becomes 0. So this would be 0 is equal to log base 2 of negative 2x plus 7. How do I solve for x here? Awesome. We start with the base, and then the other two just flip. So 2 to the power of 0 is equal to negative 2x plus 7. What is 2 to the power of 0? 1. So negative 2x plus 7 is equal to 1. Then we solve for x, so I'm going to subtract 7 on both sides. So negative 2x is equal to negative 6. Divide by negative 2. So x is equal to 3. So that was my x-intercept, which is a coordinate point. So it's going to be 3, 0. So on my graph, I'm going to plot my vertical asymptote. So that's going to be a vertical line through 7/2 or 3.5. So on X, I'm going to go to the right 3.5. Put my vertical line through there. My x-intercept is 3, 0, so that would be right there. Now I know my graph is going to be on the left side of my vertical asymptote because that's where my point is. It's on the left side, but I don't know if it's going to go this way or this way. So let's look at our transformations and see what happens. If I multiply by a negative on the inside, what does that tell me my graph is going to do? Flip on the y-axis. So typically, my log graph goes like this, but now if I flip it on the y-axis, that means it's going to go that way. So my graph goes through my x-intercept, and it's in that shape. That way. So like I said, some of them, depending on which way it goes, it will have a y-intercept, but you would need a calculator to find it, and you're not going to have a calculator for this, so you won't have to find it. The domain. So looking at my graphs go from left to right for the domain. Looking at the x values. What do you think my domain is? Awesome. -infinity to 7/2. So it's always going to be that same number as your vertical asymptote. But it's just either going to start at -infinity or go to infinity. But here, since we're going in the left direction, it's -infinity. Yes? All right, let's solve some of the ones on the bottom. So we're solving using the one-to-one property, which just means if we have the same base, we can cross them out and just set the exponents equal to each other. So this would be x plus 3 is equal to -6x minus 3. And we solve for x. So here I would add 6x to both sides. Subtract 3. So this would be 7x is equal to -6, and then divide by 7. So you just need your bases to be the same, and then just set the exponents equal to each other. So let's do number 6. Since here our bases are not the same, how can I get them to be the same? So I can make them both have a base 3. So 9 is 3 squared. So I'm going to change 9 to be 3 squared, but it's 3 squared to the power of 2x. And then what would I have to do to make 27 have the base of 3? 3 cubed. So this would be 3 to the third power to the power of 2x minus 4. Now what do I do if I have a power raised to a power? Multiply. So this would be 4x is equal to, and then here I would have to multiply also, but we just have to make sure we distribute. So this would be 6x minus 12. And then we solve for x. So I'd subtract 6x on both sides. -2x is equal to -12. Divide by -2, so x is equal to 6. All right, 7. How can I get these to have the same base? So I can make x be negative and make this 4 to the power of -x. Still don't have the same base, but I'm a little bit closer. What do you think would be my common base between these two? 2. So I can make 4 2 squared. So that's 2 squared to the power of -x. And then what would 8 have to be? 2 cubed. So 2 cubed to the power of -3x plus 2. So now I have a power to a power. I multiply them, so this would be -2x. And then here I would have to distribute. So -9x plus 6, and solve for x. So for this one, we get x is equal to 6/7. All right, last type of questions are our compounded interest questions. So if it's compounded continuously, That's when we have the formula P times E to the power of RT. If it is not compounded continuously, we have our other formula, which would be P times 1 plus R over N to the power of NT. All right, so P is our starting amount. What is R? The rate, but what does our rate have to be in the decimal version? What's N? The number of times that it's compounded per year. So if we had quarterly, what would our N be? 4. If we had monthly, what's N? 12. And then what's T? Time, so how many years? Perfect. So let's do 8. So my P is the starting amount, which was 24,500. My R is what? 0.027 because I move it twice, so it would be 0.027. And then N we said was 4, and T we said was 4. So we plug everything in and put it into our calculator. So 24,500 times 1 plus 0.027 over 4 to the power of 4 times 4. When it's compounded continuously, we use E. So P is the same thing, our starting amount, so 24,500. E is just a button in our calculator, and it's to the power of 0.027 times T, which is 4. And then we would just put this in the calculator.